What's up guys, this is Masi, welcome to my channel. Last video I talked about autoionization of water, and in this video I will talk more about concentration of proton and concentration of hydroxide ion and their relationship. So if I go back a little bit, we had autoionization of water, and I said in pure water, concentration of proton and concentration of hydroxide ion are the same, and it's equal to 10 to the power of negative 7 at 25 degrees Celsius. Sometimes we are not dealing with pure water, we have somewhat acidic or basic conditions, so that's why in those cases the concentration of proton and concentration of hydroxide ion are not equal. So one of them can be more than the other. So let's check all these three possible situations. Sometimes we are dealing with a neutral solution. Doesn't have to be pure water, but when we are dealing with a neutral solution, the concentration of proton and the concentration of hydroxide ion are equal. Case 2, an acidic solution when the concentration of proton is greater than concentration of hydroxide ion, and in a basic solution the concentration of hydroxide ion is greater than the concentration of hydronium or proton concentration. In each case, however, at 25 degrees Celsius, Kw is constant. So it means that doesn't matter if any of them greater than the other, but the multiplication of these two concentration is always constant at 25 degrees, and it is equal to 10 to the power of negative 14. Let's do some calculation. Calculating proton concentration and hydroxide concentration. Calculate proton or hydroxide as required for each of the following solution at 25 degrees Celsius, and state whether the solution is neutral, acidic, or basic. Part A, we have 1 times 10 to the power of negative 5, B, 10 to the power of negative 7 mole per liter hydroxide, and C, 10 mole per liter proton. So in the first case, we had 10 to the power of negative 5 concentration for hydroxide ion. We know proton times hydroxide ion is 10 to the power of negative 14. So if we want to find the proton concentration, it's going to be 10 to the power of negative 14 divided by 10 to the power of negative 5. That will be 10 to the power of negative 9. So since the concentration of hydroxide ion is greater than concentration of proton, we say that the solution is basic. Part B, the concentration of hydroxide ion is 10 to the power of negative 7. So proton is going to be 10 to the power of negative 14 divided by 10 to the power of negative 7. That will make it 10 to the power of negative 7, which we have a neutral solution. Why? Because the concentration of proton and the concentration of hydroxide ion are the same. Part C, the concentration of proton this time is 10. So we need to find out the concentration of OH minus or hydroxide ion. So it will be 10 to the power of negative 14 divided by 10, which makes it 10 to the power of negative 15. So as you see here, the concentration of hydroxide ion is much less than the concentration of proton. So we are dealing with a highly acidic solution. Let's do another example. At 60 degrees Celsius, the value of Kw is 10 to the power of negative 13. You remember, we had 10 to the power of negative 14 at 25 degrees Celsius. Using Le Chatelier principle, predict whether the reaction 2H2O, H3O plus, and plus OH minus. Is it exothermic or endothermic? You know, exothermic, if it requires energy for reaction to proceed. Endothermic, it requires energy for the reaction to proceed, and exothermic, it releases energy at the end of the reaction. So basically, when we are dealing with exothermic reaction, one of the product is energy as heat most of the time. For endothermic, one of the reactant is heat. Part B, Calculate proton and hydroxide concentration in a neutral solution at 60 degrees. So let's do the part A first. So Kw increases from 10 to the power of negative 14 to 10 to the power of negative 13 at 60 degrees Celsius. So when we increase temperature, the value of Kw increases. So Le Chatelier principle states that if a system at equilibrium is heated, it will adjust to consume energy. Since the value of Kw increases with temperature, we might think of energy as a reactant, and so the process must be endothermic. So since with higher temperature, we have higher value for Kw, it means that we are dealing with an endothermic reaction. Part B, we need to find out the concentration of proton and concentration of hydroxide. So H times OH is going to be 10 to the power of negative 13. So when we find the square root of 10 to the power of negative 13, we are dealing with 3 times 10 to the power of negative 7 mole per liter. I hope you liked this video. If you enjoyed it, please like this video, and if you have any question, leave me a comment and I'll get back to you as soon as possible. And don't forget to subscribe to this channel. You can find out lots of videos regarding chemistry and math. Thank you and have a great day.